time and thus result in transportation. The transportation of materials, it's depend on their material density, viscosity, and velocity of the agent. Here, the material, when it is carried out or when it is going to be transported to one place to the another place, and it's not it is not depend on the control of gravity. It's normally it will be transport. It may transport and may it remain the solution indefinitely. The reverse, it may carry the material either bed load or into the suspension or in the solution mode. Another one, it is a wind. Wind, it's a most effective agent for transportation. The wind, it's a break up the transportation material into the finer particles and around of the sharp edges of fragments. The grains transported by wind, it's a show the perfectly spherical forms, and it is indicating the very long transportation and homogeneity and uniformity. It is maintaining with that one. Yeah, the dust and more rarely find sand and carries a suspension upward much high into the atmospheric layers for a longer distances by turbulently the rising air. Its currents are due to the volcanic explosions and others also it's required. Finally, it is going to be a deposition. Sorry. In a deposition, the final destination after completion of the transportation of raw material, it is going to be deposited. The deposition, where it is occurred. The deposition, it takes place when the velocity of the transportation agent, it is checked or change in their physical or chemical conditions wherever it's occurred. The nature variations in mineralogical compositions of any sediment deposits. So depend on the following factors. The first one, it is the composition of a source of a rock. It is subjected to the weathering. Second one, it is a degree and mode of weathering. Third one is the modification of a sedimentary material which occurs during the transportation. And fourth one is the speed of agent, that's also required. The nature and amount of a sedimentary load and its a distribution. The depositional environments, it's all difficult to classify in detail because they are influenced by so many factors. The most obvious differentiation, it's between marine and non-marine deposits. Sometimes it's a continental environment. It's based on the site of a deposit. According to that, this deposition will be done. The material, it's carried out suspension or in other way. The agents, it's deposited mechanically due to the checking the velocity. Such deposits, it's known as a clastic rocks or detrial rocks. Sometimes the material, maybe it is carried out in a solutions. It's maybe deposit either on land or maybe sometimes it is in water. That's depend on their physicochemical process, such as precipitation, evaporation by the organism. Such deposits, it's known as a non-clastic or non-detrial rocks. Here we may find out it's a two types of deposits or two types of sedimentary rocks. One, it is a clastic rocks, and second one, it is a detrial rocks. Second one, it is a detrial rocks. The material is carried out in a suspension. Is a deposited layer after layer. Each layer called a bed. It has a characteristic features like a color, texture, and hardness. We have to see that is a cohesion and composition of composed approximately. It's a parallel to the each other. There is a such differentiation differentiation. The beds, it is looking into the formation, it is a different also. The plane separating the one bed from to another, it is called called as a bedding plane. Bedding plane means it's separating the one bed to the another. That is called as a bedding plane. And if the bed is very thin, or if the bed it is very thin, or it's a paper like, or the thin maybe if it is less than 1 centimeter thick, it is known as a lamina. It is known as a lamina. In examinations, they will ask, suppose if the bed it is very thin, less than 1 centimeter, dash it is called as. It is called as a lamina. If the bed it is thick, more than 1 centimeter, it is known as a stratum. If the deposition, if it is in still water, the material it is deposited in a graded manner from coarser at the bottom and finer at the top. Yes, definitely. Yeah, please wait. Please wait. Yeah. Yeah, actually in the deposition, if it is still, it is water. So what happened? As per size and a shape, the big size material or a coarse size material, it will be go down and they will be settled down in a down area. And the finer material, whatever fine particles are very fine material, those will be settled down on a top. So here, these are all will be done as a process. If the position takes place, if the deposition takes place in a running water, or sometimes maybe it is in a graded place. If it is taking the graded gradation place, the coarse material, it's going to be down. The coarse material, it is going to be down, and the fine material, it is settled down on a top. This type of horizontal or lateral gradation, it is producing by this one. Maximum the process, it is it will be happen with the repeat and repeat. It's a repeat and repeat. So this productivity or this type of production or a formation, it is called as a stratification. It is called as a stratification. By the same material, it is produced and it is deposited. The deposited, it will be done as a unconsolidated. It is a unconsolidation material. Here, in unconsolidation, the layers, it's a pile up. Pile up means group of a formation. It's a one over the other. Suppose the pressure, it will be increasing on the underlying and its unconsolidated sediments, and the water, it's occupying in small spaces of the internal body, and the grains which are gets squeezed out, and the grains to become interlocking due to the mutual molecular contact. So here, the binding, it is going to be started. It's known as a binding or a cementation. Yeah, these binding substances are commonly, it's a supplying by the percolation of a water. The most common such materials, the most common materials, or maybe it's a carbonates of calcium or a magnesium, or sometimes maybe it is oxides also. Yeah, this process, it's a welding and cementation. So generally, which it's acting together to the making of a very hardened and consolidation of a sediment material, and it leads to formation of a sedimentary rock. Yeah. Sometimes the sand, it is going to be changed as a sandstone, and mud, it is going to be changed as a mudstone, and clay, it is a change into the shale. The most common minerals which occurs in sedimentary rocks, we know that is a quartz, clay minerals, or feldspars, gypsums, anhydrite, calcite, muscovite, garnet, epidote, and most examples that sandstone. Maximum it's a contain quartz and the limestone, and it's made up of calcite. Limestone it's made up of calcite. Sandstone we know that that's a 99% contains quartz, and limestone is containing the calcite. Some of the sedimentary rocks, we see these the sedimentary rocks actually it's two types. One, it is originated elsewhere, that's allogenic. Second one, it is formed placed in this on a spot. It's orthogenic, generated elsewhere and transported to the place of a deposition. Yeah. But when you come into these orthogenic minerals, which are formed at the site immediately where they were generated, and that place only they are settled down or they were deposited at a deposition. Coming to the sedimentary rocks and their properties. The sedimentary rocks are those formed by the deposition of different solid material, and it's carried in the suspension by the agents of a transport. And their properties mainly it has a mineralogical, textural, and structural characteristics. And the characters give us information regarding the conditions of a deposition, the extent of denudation, mode of transport, climate, and other paleogeographical conditions also it's playing very important role. When coming to the mineralogical composition or mineral composition, the minerals of sedimentary rocks, it's fall into the two groups or two categories. One, it is a soluble, insoluble residue of a rock decomposition. And another one, it is comparatively wait, please. Yeah. The mineral compositions in sedimentary rocks, it's fall into the two categories. One, it's the insoluble residue of a rock decomposition. And second one, it is a comparatively durable minerals which are derived from the pre-existing rocks. From these two rock formations, particularly it's going to form as a clay minerals like a kyanite, holosite, and the micaceous minerals including the hydromicas and chlorides. And some of the aluminum hydroxides also, like example for bauxite, gibbsite, and other relation of iron ore oxides and iron hydroxides will be also formed. The maximum huge number of minerals which species are found in the second class. That is the quartz. It's always, we know that the most it's abundant. Certain it's accessory minerals such as zircon, rutile, tourmaline, garnet, kyanite, magnesite, etc. These are all frequently present in a sediment. And finally, it is going to be formed as a sedimentary rocks. Yes, certain rock form minerals, it's a susceptible to decomposition. It's may also seen in sometimes in sedimentary rocks. Thus, halvenes may occasionally be found in the shore sands. Sometimes we may identify that is in feldspars, or also it's seen in sedimentary rocks. The mineral composition of a sediment, it's affected by two or many factors. The insoluble reduces of a rock decomposition. It's usually from chief constituents like clay. There, the sand it's consisting of a quartz and feldspars. The grain size of this quartz and feldspars are similar to sands of source rocks. The mineral composition also depends on the nature of a rock and farming, whether it's gathering the ground minerals or not. In certain times, we see in a country rocks, it may consist mainly